Hello all. So in this video we will see what is the definition of stress, what is the definition of strain, and what are the different types of stress and strain we have. Okay. So coming to the first parameter called stress. So what actually is stress? See, whenever you load any object, the internal resistance offered by that object against this loading in order to get not to get deformed is called as stress, and we generally denote stress by sigma. So when I told it is the internal resistance offered by the material against loading, so that internal resistance will be mathematically equal to the loading which is coming from out. So load by the cross section area on which the load is acting will give us the stress at that particular point or on that surface. So stress sigma is given by, mathematically formula is F by A or P by A, where F or P stands for the load by the area on which the load is acting. So since stress is load by area, the units will be Newton per meter square or Newton per mm square. So 1 Newton per meter square is called as Pascal, and 1 Newton per mm square is called as megapascal. Okay. Next, coming to the different types of stresses. We have various types of stresses depending upon the way the load is falling on the surface. So basically we have the major broad classification is of three types. We have direct, which is also called simple stress, we have indirect, and we have combined. So coming to direct stresses are again of two types. We have normal stresses and shear stresses, whereas normal stresses are again classified into tensile and compressive. Indirect stresses are of two types, torsional stress and a bending stress, and combined stress will be the combination of any of the cases. Okay, so coming to first one, the first classification which you have seen is direct stress or a simple stress, which is of two types as told earlier. We have normal and shear. Normal is again of two, tensile stress and compressive stress. So if you observe tensile and compressive, this stress is developed based on the kind of loading which is falling. For example, actually first of all, before we go into tensile and compressive stress, we so call it as a normal stress because the load is acting normally or perpendicularly to the area. Means suppose if this is an object, the load is acting like this, you call it as a, then the stress induced in this object is called as a normal stress. Means the surface on which the load is acting and the load are always perpendicular to each other, that you call it as a normal stress. And normal stress is of two types as told, tensile and compressive. So tensile stress is when, if you observe the same object here, there is a bar element here, you can see there is a load P which is acting in outward direction. So tensile, this outward direction, if you see, this is called as a tensile loading, which means the load is trying to tense the member, elongate the member, or it is like a pulling action. This is called as a tensile load, and the stress which is developed in this member because of this tensile loading is called as tensile stress. So the pulling action of two equal and opposite forces is called as tensile stress, and we denote, I already told, we denote stress by sigma, and tensile stress is denoted by sigma T. So the internal resistance offered by the material against this tensile loading is your tensile stress, which will be equal to again load by area. So sigma T is again the tensile load which is acting on the member by the cross section on which it is acting. So you can see here the load is horizontal and the surface is vertical. So it is a normal stress. Next is compression. So tensile and compressive are opposite to each other. So when tensile load is a pulling type of loading, then compressive will be a pushing action. Means if you see in this diagram, the load P is trying to compress the member. It is trying to push the two edges of the member. So this kind of pushing or compressive kind, or trying to reduce the dimension of the member in length is called as a compressive loading, and the stress induced or the resistance against this compressive loading is your compressive stress. So we denote compressive stress by the symbol sigma C, which is again given by the formula P by A. So again you can see here the surface is vertical and the load is horizontal. So it is a kind of normal stress. Next, we have seen the other part of direct stress. One is normal stress, second one was shear stress. What is shear stress? So when we talked about compressive and tension, we told it is normal stress, means the surface and the load are perpendicular to each other. But if the surface on which the load is acting, the surface and the load are parallel to each other, then you call it as a shear stress. So basically, shear stress is that kind of stress or the resistance which is developed inside a member when two equal forces, of course, act tangential to the surface, means act parallel to the surface but in opposite directions. So now you can see here the area and the forces are parallel to each other. There is nothing like perpendicular, because when this is the area, if the load falls something like this, we could have called it as compression or tension, because we could have called it as normal stress. But now it is sorry yeah, but now it is area and the force are parallel to each other, so that is called as tangential action and you call it as a shear stress. Okay, so generally shear stress acts parallel to the surface, and you give the formula, you denote shear stress by the symbol tau. Okay, and it is given by again force by area. Stress is always force or load by area, but we have to see in which direction it is acting. Next, coming to strain. Okay, just now we have seen stress is nothing but the resistance offered by the material against loading so that it should not deform. But there comes some point of time where the resistance is not sufficient for the member to take that load. So once its resistance is over, what it will do? It will deform. So that deformation which occurs in a body due to loading is called as strain. And we mathematically define strain as change in dimension to original dimension. So when we are saying it is deformed, either it was deforming means its original shape is changing, correct? So that change in the shape by the original shape is called as strain. Okay, it could be any dimension. It could be dimension in terms of length or width or depth or diameter or breadth or uh, whatever kind of dimension it is. Original change by original will give you the strain, and generally we denote strain by the symbol small e, and some people also use it epsilon. Anything is same. Okay, and as I've told, strain is change in length by original length. There will be no units for strain. It is a dimensionless entity, because change in length by original length, the dimensions will get cancelled. Coming to the different types of strains we have tensile strain, compressive strain, shear strain. So these three we have seen for tensile stress, compressive stress and shear stress also. Next we have temporary strain, permanent strain, longitudinal strain, lateral strain and volumetric strain. So let's see all of these kinds now. Coming to the first one, which is tensile strain. So again let's take a same element, and I told tensile means the load will be pulling. So there is a P load acting on either side which is trying to tense the member. So once the resistance of this material is out, what it will do? It will deform. Since it is a pulling load, the deformation will be a tensile deformation, means the length will increase. So L is the original length of the material and DL is the increase in the length of the material due to this tensile action, because on either sides we are pulling the material. So that is called as tensile strain. So tensile strain is it is denoted by ET. As I've told, we can use ET or epsilon T, anything is okay, which is increase in length by original length. Next we have compressive strain. So again compression is opposite of tension. So if you take the same element and you apply a compressive loading, this compressive loading is trying to compress the member, push the member inside. So there is original length L, but now due to this compressive loading, the length gets shortened, the length gets reduced by an amount of dl. So this is also deformation only, right? It should be L, but it reduced to dl. There is some amount of dl got reduced, means still deformation has happened, right? So that is called as compressive strain. So compressive strain is EC, which is decrease in the length by original length. And last is shear strain. So shear strain is exactly the distortion of the body. So sometimes if there is any tangential force acting on a member, the body can distort. Likewise in frames, it can get distorted. So that is called as shear strain. So that distortion, we measure it in terms of angle, which is phi. So the angle through which the body distorts means the angle between the original surface and the distorted surface will give us the shear strain. So shear strain is ES, which is, you can see in this figure, there was a original rectangle ABCD. When a load of P was applied at one corner, this surface, I mean this CD is not fixed. So of course when a load is acting, it will try to distort. So the distorted shape is D dash and C dash. So when the distorted shape is D dash and C dash, you can see original height is, or original dimension is AD. Distorted is from D to D dash, this got distorted. From C to C dash, this got distorted. Both are same. So now we measure shear strain, which is nothing but this phi, as CC dash by CB. So if I take this right angle triangle C, C dash and B, if I apply a tan function, tan is opposite by adjacent side. So opposite side is CC dash, by adjacent side is C dash B. And even CB. Even if I take this side, it would become D dash by AD. Next is temporary strain. As the word suggests that the strain is temporary. Likewise, what we observe for elastic materials like rubber bands. Any elastic material, once you apply the load, what will happen? It will deform. But since it is by nature elastic, once you remove the load, we know elastic materials are those which regain their shape once you remove the load. So once the load is removed, the material comes back to its original position. Means what is happening? The deformation is restored. Means the strain is restored. Such type of strain is called as a temporary strain or a elastic strain. Next we have permanent strain. So the word itself is telling permanent, which is plastic. So any material, once you keep on applying the load, there comes a point where the material enters into the plastic zone, where the deformation would be permanent. Even after the removal of the load, the deformation doesn't come back to its original position, which means you can observe very clearly the deformed shape of the object. That's called as permanent strain. So when you remove the load, if the strain is not disappearing or the deformation is not disappearing, you call it permanent strain. Next we have longitudinal strain. So longitudinal strain is particularly regarding the longitudinal dimension of a material. So if you observe this figure, all of you, this person is trying to expand this member by applying a tensile load on either sides. He is pulling this member on either sides. So what will happen? Obviously, just now we have seen in tensile strain, when a tensile load is acting, the member will try to elongate. That is called as longitudinal strain. But at the same time, if you see, what about the other perpendicular dimension? When this is getting expanded, what about this perpendicular dimension? It will reduce. So this is called as lateral straining. Okay, so indirectly longitudinal strain is, what is that is, it is the deformation along the length of the object or length of the body, so which is given by the formula delta L by L. So as I've told, lateral strain is what? Which occurs perpendicular to the length of the body. Which acts along the length is longitudinal strain. Which acts perpendicular to this longitudinal is called lateral strain. Okay, so basic examples for lateral strain will be depth or breadth or dias, like that. Okay, which is given by delta B by B or delta D by D. And the last one is volumetric strain. So when the dimensions are changing, see, let's have a small common sense. So here length is changing, length is increasing, here depth is decreasing, means automatically the dimensions of the material are changing. So when the dimension of the material is changing, indirectly the volume is also changing, right? So volumetric strain is ratio of change in volume to original volume. Okay, and we represent by EV, which is dV by V. So these are the classification of stresses and strains. So I hope you all understood the video. Thanks for watching.